Good morning. This session will try solve a problem on resultant calculation of a coplanar non-concurrent force system, which is also named as general force system. Let us see the question. Calculate the resultant magnitude, direction, and the position for the given coplanar non-concurrent force system shown in the picture. Yeah, this figure shows a non-concurrent force system. You can see there is a force acting here, there is a force acting here, and there is a force acting here. Okay, so 300 Newton at 60 degree with x-axis and 361 Newtons with some angle which is not given to be found. Similarly, 448 Newtons, angle not mentioned but given in the form of geometry. Okay, so let us first calculate the angles required. Let us say this is theta 1. Okay, so which means that this angle can be found with this triangle, which you see it here, which can be formed by this line of action. Okay, so the grid given here is 1 meter by 1 meter grid. So now you can see this is 1 meter and this total height of triangle is 2 meters. Okay, so which is now very much same here if you take this triangle also. So it is your wish to calculate the angle either with respect to x or y. So here I have considered this as theta 1. So this also become theta 1. The opposite angles will be same. So now this triangle I am considering now. This is 2 meters and it's 1 meter. So now if you see the triangle that I'm considering, I'll write here aside. So this is just 1 meter. Okay. So this is the height. Okay. Similarly, this is the line of action of the force 448 Newton. And this is what we want, the angle. This is 2 meters and 1 meter. So this tan theta 1, if you use like opposite side and adjacent side. So tan theta 1 2 by 1. So theta 1 works out to 63.4 degree. Okay. Yeah. Similarly, let us consider now 361. Okay. So which I call this as say theta 2. Okay. So as now from mathematics, it is theta 2 opposite angles. So now you see this line of action to form a triangle. So this is the triangle that I need to consider. So this is the triangle. Okay. So this is 2 meters here and this entire thing is 3 meters. So I'll write aside here. This is 3, this is 2. Okay. So now this forms a triangle. This is 3 meters, 2 meters. So now this is our theta 2. Okay. Now taking again tan theta 2. Opposite side is 2 meters. Adjacent side is 3 meters. So theta 2 will be tan inverse 2 by 3. Okay. So which you get from calculating 33.7 degree. Okay. So these two are the angles which are required because the 300, the angle is directly given to you, 60 degree. Okay. Yeah. Now let us try find the components. Okay. So we generally go for rectangular components, right? So we try resolve the given force into two components. Okay. See here, this is a horizontal component of 361 and vertical component of 361. So which is now 361 cos theta 2. This will be 361 sin theta 2. Similarly, you can see here this two are the components. Now this will be a 448 cos theta 1, 448 sin theta 1. So we found already the theta 1 and the theta 2 angles. Okay. Similarly here, the 300 force has got two components. So this will be 300 cos 60, the horizontal component, and 300 sin 60 is vertical component. I'll try now write the components, okay, in the form of a table. Okay, so let us formulate a table for uh, better working. So I take first column as force, then fx values, then fy values, means x component, y component. So let us first write a force, let us say 448 newtons. So has got 448 cos, you can see here 448 x component is cos theta 1, where theta 1 is 63.4. Okay. Similarly, whenever you get theta 2, I'm substituting 33.7. Okay. So do consider that 63.4 degree. So which works out to 200.6. Okay. And attach the sign or sense of the force here itself, whether it is towards positive x-axis and positive y-axis, like that. Okay. If it is towards negative x-axis, we assign negative sign. Okay. So likewise, you just try to attach the sign also. So if you go for y component, it is negative. Okay. If you see 448 force y component is downwards. Okay. This force is downwards. So I writing negative here, minus 448 sine 63.4 degrees. So which comes 400.6 newtons. Similarly, the next force. You need not follow any order. You can first write 361, then 448, no problem. Okay. So now I'll write the x component, which is minus 361 cos 33.7 degree. You know why I have attached negative sign for this? Okay. It is towards negative because 361 force is like this. So x component will be towards negative x-axis. Okay. And y component will be towards negative y-axis, pointing towards negative. So both are negative components. Okay. So it is minus 300.3 Newton. Similarly, y component I write minus 361 sine 33.7 degree, which works out to minus 200.3 Newton. And going for 300 Newton directly, where the angle is available. So it is minus 300 cos 60, so which will be minus 150.0, and 300 sine 60, so which will be 259.8. So you can see how the given 300 Newton is. You see here. So the x component is towards negative sign, okay, towards negative x-axis. Y component is positive. So that's why you get negative x component, positive y component. So now you need to find the sum of these components. Only three forces are available given to you. So sum of x components is coming minus 249.7 Newton. So add these according to the sign. So first add these and deduct with this. Similarly, y components sum. So summing all these according to the sign will give you minus 341.1 newtons. Okay. So these are x components and y components sum. Okay. So with this, now you can find the magnitude of resultant. So you know the formula from the parallelogram theorem that sum of x forces whole square plus sum of y forces whole square. So just substitute into this equation. So as you are squaring, the negative sign becomes positive. So 249.7 whole square plus 341.1 whole square. So total is when you calculate 422.7 newtons is the magnitude of the resultant. Okay. So next calculation is its direction. Okay. So what is the direction? First plot these components onto the coordinate system. Let us see. Okay. So this is y-axis, this is x-axis. Okay. Right. So now you see sum of x forces of all the forces is minus 249, means towards negative it is minus 249.7 newtons, and this is also negative, so minus downward. Okay, so let me just draw it to a rough scale, not to the exact scale. See, this value is lesser, this value is little more, so I give more length to the arrow. This comes 341.1. Now you just complete the parallelogram, nothing but rectangle here because the components are rectangular components. Now the diagonal of this rectangle, okay, is nothing but your resultant. Okay, so this is your resultant force R. Okay, now if I want the direction of this one, so which we say in terms of angle, let's say this is alpha, and I prefer taking with x-axis. So alpha is equal to, I'll first write trigonometric parameter like tan. So it is opposite side, means this value is equal to this value. which is 341.1 divided by adjacent side 249.7. Now the alpha is tan inverse of this value, like 341.1 by 249.7. So which works out to 53.8 degree. So this is the direction of resultant. Okay. So alpha is equal to 53.8 degree. Okay. Right. So out of three quantities asked for the resultant, you got two. One is the magnitude, which is 422.7, and the direction, it is towards negative x-axis and negative y-axis, which means if you call this as first quadrant, second quadrant, third quadrant. So when you come uh, towards anti-clockwise or towards clockwise, both, okay, it is third quadrant. So your resultant falls in the third quadrant. Okay. Yeah. Now it is time to find the position. Okay. So how you decide position means where this resultant is acting. Okay. So where you need the help of theorem of moments or Varignon theorem. Okay. So this will help you to find the position of the result, what it is. Okay. So what is Varignon's theorem and how it is going to help you? So I'll say it in simple way, like moment of resultant means resultant into the distance. Moment of the resultant will be equal to sum of moments from all the given forces about the same point. Okay. So in our case, there are three forces, right? So I'll call it as F1, D1, F2, D2, F3, D3. Okay. So if you pick a point, which is moment center, what you call. So about that point, if you calculate moment of that resultant, okay, will be same even if you calculate the moment about the same point from the three given forces. So this will help us to decide the position. Okay. So let us first draw the given forces so that we have an idea. Okay. So this is the grid given to you. Let us assume that this is a plate. Okay. And this is the x-axis and y-axis. Okay. So now I pick this point O as moment center. Let O as moment center. Okay. Now let us calculate moment of all the given forces. Okay, which are the given forces you see? So there is a 300 Newton here, which is at 60 degree, and there is 361 newtons at an angle of theta 2 that you found. which is 33.7 degree. You found it. Okay. Then you try draw this 448, which is at an angle of 63.4 degree that you found. Okay. Yeah. So these are all the lines of action. Okay. Yeah. Now find the right hand side of the equation, this equation. Okay. So we find the right hand side. So I'm not going to take directly the force into perpendicular distance. See, this is the force and this is a perpendicular distance. Okay, I'm not going to find directly. I'll take the components and I'll find the total right hand side value. Means F1 is now two forces, X component, Y component. F2 is two forces. F3 is two forces. So there are six forces now. Okay, I'll calculate right hand side moment from these six forces. Okay, so let us try do that. Okay, yeah, so it is 448 this force. Okay, so X component is passing through this point, so I'll have only Y component moment, so which means 448 sine 63.4 degree is the Y component into the distance between this point and this Y component is 4 meters. Okay, and the direction, it is clockwise. So I take clockwise as positive. Okay, a minus 361 cos 33.7 is the component into 1 meter. Okay, so this 361, if you try apply here with the principle of transmissibility, its vertical component pass through O, only horizontal component will have moment, and the distance is 1 meter. This is a force and this is 1 meter, and this is anti-clockwise. Same way, 300 sine 60 is the component, 2 meters is the distance. Okay, so, yeah, minus one more component. 300 will have two components, right? One component like this, other component like this. So the this sine component will be like this, perpendicular distance 2 meters. Horizontal component, perpendicular distance 3 meters. Cos 60 into 3. So this is the total moment of the forces. So which works out to 332.4. Okay, so this is the right hand side. Coming to the left hand side, that is this one. So resultant, okay, is like left hand side. So resultant is again two components, X component sigma fx, sigma fy. So now I'll write moment from these two components. Okay, so as you see, the resultant is falling into third quadrant. Okay, so which means this is something like this. Okay, so I'll assume that it is now intersecting x-axis first. Okay, so this distance I call it as x. Okay, now this I can write it into two components. The resultant that I have one x component, y component. X component pass through this moment center O, so zero moment. And this y component, that means sigma fy into the distance, I don't know, x. Okay, so which mean what is y component? 341.1 into x. This is left hand side. So now from the equation, that is Varignan's theorem, 341.1 x is equal to right hand side 332.4 Newton meter. So x is equal to 341.1 divided by 332.4, which is 0.974 meters. Okay, so this is the distance at which the resultant pass through or intersect the x-axis. Similarly, okay, if I extend this line of action, okay, like this, okay, I'll draw with a different color. So resultant is going to intersect y-axis at unknown distance y, this like this. So which means you have got again two components, vertical, horizontal. Okay, so vertical is passing through O, so it doesn't make any moment, only x component. So sigma fx into y is equal to right hand side. Okay, so left hand side is sigma fx. What is sigma fx? 249.7 into y is equal to right hand side is same, won't change, 332.4. So what is y value? Is 332.4 divided by 249.7. So y value is 1.331 meters. Okay, below this point O. So resultant position is exactly on x-axis it is at 0.974, on y-axis it is at 1.331 meters. Okay, so this is how the position of resultant can be easily calculated with the help of the Varignan's theorem or theorem of three moments. Okay, yeah, thank you. We'll be back with one more problem.